Hi everyone, it's Alyssa and welcome to Tricky Math Tuesdays. Today's tricky math problem actually came from a tutoring student that I have, and this was a problem that he brought to one of our sessions, and I thought it was interesting and, wanted to share it with you guys. So here's how this one goes. I have two circles that are overlapping. The radius of each of these circles is 5. These are the center points of these circles. The line connecting the two circles has a length of 8. Now they want to know what is the area of this shaded region. Okay, so first things first, we are going to be covering a couple little trig concepts in here. Just letting you know, we're going to have a sign. Sign's going to rear its ugly head. And there's a couple other little geometry things. I'll go over them as we're going along, but this isn't really an in-depth of those concepts, but it's more just the process for this particular problem. Right, so first things first, I'm going to draw a vertical line that goes right down the middle. It's not perfect, but pretty close to being right down the middle. Divide this in half. So now I have two shapes, two sides there, left side and right side. I'm also going to draw two more radii down here. Yep, we're going to turn the ink to shape feature off because it's going to mess with things. Okay, so same sort of thing. I'm doing this. Okay. So here's what I have created. I'm going to separate them to make it a little easier to see. What I've done is I now have on the left-hand side, I have a circle that has a sector. That's the name for a portion of a circle. And then there is a chord cutting it across and creates a segment. Now this segment right here, I'm highlighting in pink, is the same as this piece right there. Okay, so now I also have on the right, I have an identical sector. It's just facing the other way. And I have this other chord coming across and creating an identical segment. These are identical circles, so when they overlap, they're creating identical segments. So for this segment right here, that's the same as this left-hand side. So I could either find out the area of this, segment 1 here and segment 2 here and add them together, or I could just find out the area of one of them, then multiply by 2. That's what I'm going to do. So how do you find the area of a segment? Area of a segment is the area of the sector minus the area of the triangle. So like in, over here, this triangle that's in that sector. Right, so it's the area of the sector minus the area of the triangle. So again, the sector is the whole section, and then we just have that internal triangle. We subtract it and we'll get the area of the segment. So what's the area of this sector? Okay, well for this, we're actually going to go back. I don't know why I zoomed out. We're going to zoom in. I'm going to go back to this original drawing. This diameter looking thing, it's not a true diameter, but that's what we're kind of associating in our heads, that's connecting these two centers, is 8. This overlapping, it's cutting it in half. So this purple line that I drew here in the middle, it's cutting that 8 in half. So on the left side it's 4, and on the right side it's 4, and I'm creating right angles there. So I have just created a lovely little set of 3, 4, 5 right triangles. So I have 4, 3, 4, 5 right triangles. So that's cool. So how does that help us now? Well, now I have a right triangle. I can use my trigonometric functions. So I'm looking at this triangle here on the left. So I'm just going to draw it over here so you can really see it. It's 3, 4, 5. And I want to know this angle right here. I'm going to call it theta. So if I find out theta and then multiply it by 2, I'll have this whole angle. All right, so let's figure out what theta is. I'm just going to use sine. So I know that the sine of theta is equal to opposite over hypotenuse, or 3 over 5. Now I'm going to erase this little thing here, area of sector minus area of triangle, but don't forget about that. All right, so sine of theta equals 3 over 5. Now, this is where we get our calculators out, and we say, okay, inverse sine. Let's figure out inverse sine both sides. What is theta? And our calculator will tell us that theta, and I'm using degrees, not radians, is 36.87 degrees. All right, well, the angle I'm looking for is twice that. So that bigger angle is going to be 73.74 degrees. All right, now basically I have this circle and I have this sector, and this is 73.74 degrees, and there's a radius of 5. What's the area of the sector? This is a proportion. When we find the area of a sector, you do part to the whole for the degrees and then for the area. And here's what I mean by that. This sector, the degree is 73.74. How many degrees are in the entire circle? 360. So that's the proportion of the circle that it is. It's 73.74 parts out of 360. Well, that ratio, we can say, all right, well, how about what's the total area of this circle? Well, pi r squared is our area of a circle. Area equals pi r squared, and our radius is 5. 5 squared is 25, so the area of the whole circle is 25 pi. And we don't know the area of the sector, but it's going to keep that same 73.74 to 360 proportion. So now this is where we cross multiply. So if I cross multiply, I get 73.74 times 25 pi times 25 pi equals 360 times x. Boop, there we go. Okay, so if I multiply those, I get 1,843.5 pi equals 360 times x. Then I'm going to divide both sides by 360. And I get that x is equal to 5.121 pi. Right, so that is my area of a sector. So remember, I'm going to write it over here. Area of sector minus area of triangle. So my area of my sector is 5.121 pi. Now the area of my triangle. Well, I'm going to draw that portion of it now. I had that sector. Then I have the triangle. Well, for a triangle, we need base and height. I can look at this side as my base, and I know from my diagram up there, the top was 3 and the bottom was 3, so this whole triangle has a base of 6. And then this is the height, which I also know, that is 4. Area of the triangle is 1/2 times base times height, 1/2 times 6 times 4, or 12. So I now know my area of my triangle is 12. So that right there, 5.121 pi minus 12, is the area of this segment right there, that pink segment. Well, I have 2 of these segments stuck together. So I need to multiply this by 2. So 2 times 5.121 pi minus 12 equals, we distribute this, 2 times 5.121 is 10.242 pi, and 2 times 12 is 24. And we weren't given units, but this could be centimeters squared, inches squared, what have you. But that's it, units squared, 10.242 pi minus 24, that is all, units squared. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.